Today we're diving into an important concept of concurrency, buffered and unbuffered channels. Channels in Go are a powerful feature for communication between Go routines. They allow us to pass data from one Go routine to another, ensuring synchronized execution and avoiding common pitfalls like race conditions. But not all channels are created equal. There are two types, unbuffered and buffered. Unbuffered channels are the most straightforward type of channel. When you send a value into an unbuffered channel, the send operation blocks until another Go routine is ready to receive the value. Similarly, when you receive a value from an unbuffered channel, the receive operation blocks until there's data to be received. Suppose these two gophers represent two Go routines. They both are busy with their jobs. Go routine 1 is ready to send data on the channel, but the other Go routine is busy, so Go routine 1 waits patiently. As soon as the other Go routine is ready to read the data exchange happens on the channel. Then they both go back to their respective jobs. This is the concept of an unbuffered channel. Buffered channels, on the other hand, allow values to be stored in the channel up to a certain capacity. This capacity is defined when you create the channel. With a buffered channel, the send operation blocks only when the channel is full, and the receive operation blocks when the channel is empty. Here again we have two Go routines busy doing their jobs. There is a buffered channel between them of size 4. Go routine 1 wants to send something on the channel. It places the value in the queue and goes back to its job without blocking. It again has something and adds to the channel. When Go routine 2 reads the channel, it receives the value. This is how buffered channels work. To make an unbuffered channel, we can use a construct like this. This is the same as passing 0 as the length of the channel. The only difference that the buffered channel brings is the non-zero length of the channel. Let's use a coffee shop analogy. Suppose there is a coffee shop where a customer waits to place an order until the barista is ready to accept and prepare the order. The barista can only start preparing an order when it is received, which means the system can handle only one order at a time. Let's see how this looks as a code. Here is the main function. We begin by creating an unbuffered channel called orders of type string. This Go routine represents customers placing orders. And this code here is like a barista processing orders and brewing coffee for customers. In this Go routine, we run a loop simulating 5 customers. An order is created. It is a string containing this text with the order number at the end. Then the order is placed on the channel. This Go routine waits till the barista is ready to accept an order. This makes the other customers wait too. As soon as the barista accepts the order, we print this statement and go to the next customer. Once all customer orders have been placed, we close the channel. Now let's see how the code for barista works. Here, the barista waits for an order by reading the channel. This is a blocking call. As soon as he receives the order, he starts preparing the coffee. This sleep here simulates the time taken to prepare coffee for the customer. Next, the coffee gets served to the customer. Now the barista goes back to look for another order. This loop breaks when the channel is closed in the customer Go routine. Let's run the program. Here the first order gets placed, and it immediately got accepted as the barista was free. Here the coffee is ready and gets served. Then comes the order number 2. The processing statement comes before the order placed print, as they happen almost at the same time in different coroutines. As soon as the order gets placed, the barista starts processing the order. And then the order gets served, and so on. Now let's look at the buffered channel counterpart. In this scenario, customers can place their orders at a counter and wait elsewhere, allowing other customers to place their orders even if the barista is still busy. The barista processes orders from the counter as they come in, but has the flexibility to work through a backlog of up to 3 orders. This allows the barista to manage order preparation more efficiently, especially during surges, as the system is not entirely halted by the preparation time of each order. If we made only one change in the code, this channel is replaced with a buffered channel with size 3. Now placing an order blocks only when the buffer is full. The rest of the code remains the same. Here, the first 3 orders get placed without any wait. Then, the buffer gets full. As soon as the preparation of the first order starts, the 4th order is placed. Here, we saw that the customers would get blocked only when the buffer was full. Similarly, the barista will wait if the buffer is empty. Now we understand the difference between unbuffered and buffered channels. Let's see what are the advantages of using buffered channels. It decouples the producer and the consumer by putting a queue between them. It is great for handling bursts of traffic again by providing a buffer. By unblocking the goroutines, it improves throughput. These properties of buffered channels make them useful for worker pools and for asynchronous signaling. And there you have it. A comprehensive guide to understanding buffered and unbuffered channels in Golang. Remember, the choice between them should be guided by your application's specific requirements for synchronization and performance. If you enjoyed this tutorial, don't forget to like, share and subscribe for more programming insights. Until next time, happy coding.